We want to take a look now at some of the multiplication properties of exponents. And the first property that's written in the book, I've written over here on the board. A to the r times a to the s is a to the r plus s. Now this property says when you're going to multiply two expressions that have exponents on them and they both have the same base, you can just take that base and raise it to the sum of the powers. So multiplication with the same base results in addition of exponents. Now, to see the justification for this property, you have to look through the book and look in the book in this section and see how we've derived that property. All we want to do here on the videos is use the property. So if we're assuming that a to the r times a to the s is a to the r plus s, we can simplify a to the third times a to the fifth by writing this as a to the 3 plus 5. I simply add exponents, and that gives me a to the 8th power. Now, that's correct also intuitively to us because this is 3 factors of a, this is another 5 factors of a. That should give us a total of 8 factors of a. So a to the third times a to the fifth, using my property of exponents, is a to the 8th, and that also agrees with what we know about this intuitively. Let's try another example. 2x to the fourth times 7x to the fifth. First, I use the commutative and associative properties to rewrite this as 2 times 7 times x to the fourth times x to the fifth. Now I can multiply 2 times 7 and get 14. Then x to the fourth times x to the fifth will be x to the 4 plus 5, which is x to the 9th. So here I've applied my property 1 for exponents and didn't show the intermediate step, just simply added 4 and 5. Because every time I multiply with the same base, I can simply take that base to the sum of the exponents. X to the fourth times x to the fifth is always x to the 9th. Here's another example. A little more complicated. I've got numbers, a variable x, and a variable y. I'll start by using the commutative and associative properties, rewriting this as 3 times 2. I'll take care of the number parts. Then x to the second times x to the third, and then y to the 7th times y squared. So that's simply changing the order and the grouping of the numbers. But all the factors that I have down here are the same exact factors that I have up here. It's all multiplication, so I can change the order and the grouping anytime I want. So that's what I've done to make it convenient for myself. Now I'm going to simplify. 3 times 2 is 6. X squared times x to the third is x to the fifth. Y to the 7th times y to the second is y to the 9th. So in both cases, I add exponents on the same base. Here the base is x. I add those 2 exponents and get 5. Here the base is y. I add those 2 exponents and get 9. Now let's look at our second property of exponents that has to do with a power raised to a power. When we have a to the r all raised to the s, that is a power raised to another power, that's the base raised to the product of those 2 powers. So a to the r, all raised to the s, I have to have these parentheses, is a to the r times s. Applying that to this expression, I have x to the 2 times 5. So I multiply exponents because I see I have a power raised to a power. And that will be x to the 10th. Now, that makes sense to us intuitively also because this is 2 factors of x. And that is written down 5 different times. If I was to take this exponent right here, I would write down x squared 5 times as a factor. Each of those x squareds is 2 factors of x, so I have a total of 5 groups of 2 factors of x. That's 10 total factors of x. So it makes sense that I'll multiply 2 times 5 to get 10 here when I have this situation. Here's another example of this. Problem number 5, we want to cover one more property of exponents before we do an example of the second property again. Here's this time I'm going to use this third property that says that a product a times b raised to the r is a to the r times b to the r. What this property of exponents says is that exponents distribute over multiplication. So a times b all raised to the r power is a to the r power times b to the r power. So let's apply this property number 3 for exponents to this expression. I have 2ab to the third power. Well, what this property says is I can write that as 2 to the third times a to the third times b to the third. So I take each of the factors in this product and raise them each individually to that exponent. 2 to the third, a to the third, b to the third. Now that turns out to be 8, a cubed, b cubed, because 2 to the third power is 8. So there's my third property of exponents right there. Now what I want to do is simplify this expression, and it will require using two of the properties of exponents in combination. So first of all, I see I have this 3 that I'm going to distribute over the 5 and the y to the 4th. That's using my property 3. So I have 5 to the 3rd power and then y to the 4th. That raised to the 3rd power. So here's one factor, here's the second factor. Each of those factors, since this is multiplication, is raised to the 3rd power. 5 to the 3rd, y to the 4th to the 3rd. Now, 5 to the 3rd power is 125. Y to the 4th to the 3rd, I'll use property 2 for exponents that says if I have a power raised to a power, I multiply exponents. That will be y to the 4 times 3, which is y to the 12th power. So two properties of exponents in combination to simplify this expression right here. Now, my last problem that I want to do here is even more complicated, and we're going to use all the properties of exponents, all three properties that we have. First, let's apply this property 3 and distribute this exponent over these three factors in this product. It'll be 3 to the 2nd, x to the 3rd to the 2nd, y to the 5th to the 2nd. So I'm going to write that down. 3 to the 2, x cubed to the 2nd, y to the 5th to the 2nd, times 2 to the 3rd. I do the same thing to this expression and take all three of those factors and raise them to the 3rd. So 2 to the 3rd, x squared to the 3rd, y to the 4th to the 3rd. Now, I'm going to simplify, going left to right here. 2 to the 2nd is 9. X to the 3rd to the 2nd power, I want to multiply exponents here. X to the 3 times 2 is x to the 6th. Y to the 5 times 2 is y to the 10th. Times 2 to the 3rd is 8. X squared to the 3rd, I multiply exponents and get x to the 6th. Y to the 4 times 3 is 12. Now, I'm going to use the commutative and associative properties to regroup. So it'll be 9 times 8. Rearrange the order in the grouping. X to the 6th times, this x to the 6th. And then y to the 10th. Times y to the 12th. So I've grouped the numbers together, the x's together, and the y's together. Okay, 9 times 8 is 72. X to the 6th times x to the 6th is x to the 12th. Y to the 10th times y to the 12th is y to the 22nd. So here is property 1 for exponents where I multiply with the same base. I have to add exponents. So x to the 6 plus 6 is x to the 12th. Y to the 10 plus 12 is y to the 22nd. So sometimes I add exponents, sometimes I multiply exponents, and sometimes I distribute exponents over products. There's three separate properties of exponents that apply to multiplication, and each one of them applies to a different situation. What you need to do is look at those properties of exponents and work enough problems so that you know which property to apply to which situation.